There's this powerful, almost invisible system that controls pretty much everything you do on your work computer. It's the real reason you have certain software, why your background is locked, and yeah, why some websites are totally off limits. Today, we're going to pull back the curtain on that system group policy.
I mean, we've all been there, right? You try to personalize your machine just a little bit, maybe install some helpful little app, and then bam, access denied. You hit this digital brick wall. It feels so random and frustrating, but I promise you there's a very, very deliberate system making those calls. And that system is called group policy. You can think of it as the central nervous system for managing all the users and computers on a Windows network. It's the thing that makes sure everyone, from the CEO down to a summer intern, has exactly the right permissions and settings to do their job and nothing more.
So, how does this whole thing actually work? Well, the key to really getting group policy is understanding that it's not just one giant list of rules. Nope, it's a carefully structured cascade where different policies are layered on top of each other in a really specific order. And this is that fundamental order. It's called LSDOU, and it goes from the most general rules down to the most specific. First up, any policies on your local computer get applied. Then, policies for your physical office location, what they call a site. After that, the big company-wide rules or domain policies kick in. And finally, the most specific rules for your particular team or department, the organizational unit or OU, are applied last. And here is the single most important rule to remember from that whole process. The last policy applied wins. Just like Microsoft says right here, the rules that are closest to you, like the ones for your specific department, will always override the more general company-wide rules. So if a big company policy says no custom desktops, but a policy for the marketing OU says custom desktops are okay, well, guess what? Marketing gets their custom desktops.
That waterfall analogy is actually perfect. Each level in that order we just talked about is another stream of water pouring into the pool. The policies from your local computer, the site, and the domain, they all make ripples. But it's that final splash from your specific organizational unit that usually defines the final state of your settings.
Okay, but what if an IT admin needs to make sure a supercritical security rule is never, ever overridden? Or what if a specific team, say the R&D department, needs a totally clean slate, free from all the normal company policies? Well, the system has some incredibly powerful tools to bend or even completely break that normal cascade of rules. And that brings us to these two competing concepts. An enforced policy is like an unstoppable force. An admin can set it way up at the top level, and it will just power its way down through every single department, no matter what they want. On the flip side, you have block inheritance, which acts like a policy dam. A department can use this to just stop the normal flow of policies from washing down from above.
So, what happens when that unstoppable force meets the immovable policy dam? Well, as you can see, there's a very clear winner. An enforced policy always, always wins. It just smashes right through any block inheritance setting. You can think of it as the ultimate trump card for an IT administrator. Now, applying rules to whole departments is one thing, but modern IT needs to be way more precise than that. And this is where group policy gets really cool, because it gives admins almost surgical control to target rules with incredible accuracy. They mostly do this in two ways. Security filtering is pretty straightforward. It applies a rule only to specific people, computers, or groups, like, say, all project managers. But then there's WMI filtering, which is way more technical and powerful. It lets them target computers based on their actual specs, so they can say, only apply this setting to Windows 11 laptops, or even only apply this to computers with less than 8 gigs of RAM. It gets incredibly granular. Then we have this fascinating special case called loopback processing. Just imagine a computer in a library kiosk, or maybe a shared computer in a classroom. You don't want a student's personal settings showing up there, right? You want the computer's rules to be in charge, no matter who logs in. That is exactly what loopback is for. And it comes in two flavors. You've got merge mode, which basically says, okay, apply the user's normal policies, but then apply this computer's special user policies on top of that, and the computer's rules will win any fights. Then there's replace mode, which is much more absolute. It says, you know what? Forget the user's policies entirely. When they log on to this machine, they get the computer's user settings, and that's it. End of story. So all these policies get applied, but the system isn't static, right? It's a living, breathing environment that needs to stay updated. And this is all handled by the policy refresh cycle, which makes sure your computer is always in sync with the latest set of rules.
So, how often do these rules actually get updated on your machine? Well, by default, your computer quietly checks in with the network for new or changed policies every 90 minutes. This means if an admin pushes out a new security setting, you might not see it that very second, but it'll show up during that next refresh.
And the system is actually really smart about this. To prevent a massive network traffic jam where, say, 10,000 computers all try to check for updates at the exact same time, it adds a random offset, up to 30 minutes, to that 90-minute timer. This staggers all the requests and keeps the network from grinding to a halt. But of course, sometimes waiting for an hour and a half just isn't an option, especially if it's for a critical security update. In those moments, admins have a bunch of ways to force an immediate refresh, whether it's by running a command directly on your machine or by pushing an update to an entire department from their central console.
Okay, so we've looked at the cascade, the exceptions to the rules, the surgical targeting, and the update cycle. When you put all of these pieces together, you start to see the bigger picture of what group policy is really designed to do.
Ultimately, it is all about control and consistency. It's what ensures that every single machine is configured correctly, that security settings are always in place, and that users have access to exactly what they need, and only what they need. It's the hidden architecture of a stable and secure corporate network.
So, the next time you find you can't change your wallpaper or access a certain setting, you'll know it's probably not a glitch. It's a policy. Now that you see the logic behind it all, take a look at your own digital workspace. How many of these invisible rules can you suddenly see in action all around you?